Hey y'all, please don't mind this right here. If you've watched my previous video, it decided to fall halfway through and I'm gonna leave it here for this video as well. So ignore it. Are you trying to understand data visualization in Python using Seaborn? If so, this video is for you. In today's video, we will continue our Python for Data Science series and discuss data visualization. More specifically, I will go over an introduction, discuss setting up Seaborn, basic Seaborn plots, customizing aesthetics, advanced plot types, categorical data visualization, Facet grids and multi-plot grids, plotting regression models, enhancing plot visuals, integrating Seaborn and other libraries, practical examples, case studies, and some best practices. That was a lot. As always, my video is timestamped, so if there's a specific section that you'd like to skip to, you can do so by clicking down in the description. So let's get started and let's tech talk with Tyler. Before we dive into the exciting worlds of creating stunning visualizations, let's back up and start with a brief introduction to Seaborn. Seaborn is a powerful Python data visualization library built on top of matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphics. So with Seaborn, you can create complex visualizations with just a few lines of code, making it an essential tool for any data analyst or data scientists. Why is data visualization so important? Imagine you have a data set with thousands of rows and columns. Understanding trends, patterns, and outliers just by looking at raw numbers would be extremely challenging. This is where data visualization comes in. So by transforming data into visual representations like charts and graphs, we can make complex data more accessible, understandable, and usable. Efficient data visualization helps us to quickly grasp insights, identify correlations, and communicate our findings clearly to others. To get started with Seaborn, the first step is to install it. So if you haven't already installed Seaborn, you can easily do so by using pip, which is Python's package installer. Open up one of your command line or terminals and type the following command: pip install Seaborn. This will install Seaborn along with its dependencies. Once the installation is complete, you're ready to go and you're ready to start using Seaborn in your Python projects. Next, we need to import Seaborn into our Python script. We will also import matplotlib, which Seaborn is built on top of, and pandas, a popular data manipulation library. These libraries will help us create and customize our visualizations. By importing these libraries depicted in the code snippet, we have all the tools we need to create beautiful visualizations throughout this video. Seaborn comes with several built-in data sets that we can use to practice creating our visualizations in this video. So for this video, we will use the tips data set, which contains information about tips received by a waitstaff in a restaurant. This dataset is great for practicing various types of visualizations. We can load the dataset using the following code snippet, and to get a quick look at the data, we can display the first few rows using the head method. This will give us an idea of what the data looks like and what columns are available to us for visualization. Before diving into advanced visualizations, let's quickly recap some basic Seaborn plots. These foundational plots will set the stage for more complex visualizations. We'll cover the line plot, bar plot, and scatter plot, which are commonly used for data analysis. A line plot is useful for visualizing data points in a continuous line, showing trends over time or another continuous variable. Let's create a simple line plot using the tips data set to visualize a relationship between the total bill and the tip amount. This line plot code snippet will generate a line plot where the x-axis represents the total bill and the y-axis represents the tip amount. The plot.show function displays the plot. Bar plots are great for comparing quantities across different categories. So for example, we use the bar plot to compare the total bill amounts for different days of the week. The bar plot code snippet will generate a bar plot with days of the week on the x-axis and total bill amount on the y-axis. Each bar represents the average total bill for that day. Scatter plots are used to visualize the relationship between two numerical variables. They are useful for identifying correlations and patterns in the data. Let's create a scatter plot to visualize the relationship between, let's say, total bill and the tip amount. This scatter plot code snippet will generate a scatter plot with the total bill on the x-axis and the tip amount on the y-axis. Each point represents a single observation in the data set. One of the greatest features of Seaborn is the ability to easily change the look and feel of your plots using themes and styles. Seaborn offers several built-in themes to make your plot more visually appealing and aesthetic. So for example, you can use the white grid theme for a clean, grid-based background as shown in the code snippet. You can also set the context to control the scaling of plot elements, such as labels and lines, making your plot suitable for different contexts like presentations or reports. Colors play a critical role in data visualization, helping to differentiate data points and making plots more engaging. Seaborn provides several predefined color palettes that you can use to change the colors of your plots. For example, you can use the pastel palette for softer colors. If you want to create a custom color palette, you can define your own set of colors. In this code example, we define a custom palette with 3 colors: blue, red, and green. You can use any hex color codes to create your custom palette. Depending on where you plan to use your plots, you might need to adjust their size. For example, plots in a report might need to be smaller, while plots in a presentation might need to be larger. You can easily change the size of your plots using matplotlib's figure function. Displayed is a code snippet to set the plot size to 10 inches wide by 6 inches tall. By adjusting the figure size, you can ensure that your plots are the right size for their intended use, making them more effective and easier to read. Pair plots are a great way to visualize relationships between multiple pairs of values in a data set. They provide a matrix of scatter plots and histograms, showing the distribution and relationships of each pair of variables. Let's create a basic pair plot using the tips data set. This code snippet will generate a grid of scatter plots and histograms for all numerical variables in the data set. You can customize pair plots to make them more informative and visually appealing. So for example, you can use the hue parameter to color the data points based on a categorical variable, and the kind parameter to specify the type of plot, such as scatter, KDE, or histogram. You can also use the markers parameter to specify different markers for different categories. So many customizations possible. So in the example of a customized pair plot, the data points are colored based on the sex column, and different markers are used for each category. This makes it easier to distinguish between different groups in the dataset. Heat maps are useful for visualizing matrix-like data, such as correlation matrices. They use color to represent the magnitude of values, making it easy to see patterns and relationships. Let's create a basic heat map to visualize the correlations between variables in the tips dataset. This code snippet will generate a heat map with a color gradient from cool to warm colors, representing the correlation values. The annote equals true parameter adds the correlation values to the heat map cells, annote standing for annotation. You can customize heat maps to make them more informative and visually appealing. For example, you can change the color map, add annotations, and adjust the line width and colors between cells. Here's an example of a customized heat map. In this example, we use the YIG NBU color map for the green to blue gradient. Add annotations with the correlation values, and add white lines between cells for better separation. Violin plots are a great way to visualize the distribution of categorical data. They combine aspects of box plots and kernel density plots to show the density of the data at different values. Let's create a violin plot to visualize the distribution of total bills across different days, split by gender. This code snippet generates a violin plot where the x-axis represents the days of the week and the y-axis represents the total bill. The data is split by gender, providing a clear comparison between male and female distributions. Box plots are another effective way to visualize the distribution of data across categories. They display the median, quartiles, and outliers of the data. Let's create a box plot to compare the total bill distributions across different days, split by gender. So this code snippet will generate a box plot where the x-axis represents the days of the week, and similar to the previous one, the y-axis represents the total bill. The data is split by gender, showing the central tendency and variability within each category. Swarm plots show the distribution of data points for categorical variables. They arrange the points to avoid overlap, making it easy to see the concentration of data points. So let's create a swarm plot to visualize the distribution of the same example, total bill across different days, split by gender. This code snippet generates a swarm plot where the x-axis represents days of the week and y-axis Total bills, correct. The data points are split by gender and arranged to avoid overlap. So for enhanced visualization, you can overlay swarm plots on box plots. This combination provides a clear view of the data distribution while showing the central tendency and variability. Here's how to combine a box plot and a swarm plot. This code snippet will first create the box plot and then overlay with a swarm plot on top of it. The color equals 0.25 parameter makes the swarm plot points semi-transparent, allowing the box plot to remain visible. Facet grids are an excellent way to visualize data across multiple subplots, allowing you to break down your data by multiple variables. This makes it easy to see patterns and relationships within subsets of your data. Let's create a Facet grid to visualize the relationship between the total bill and the tip, split by gender and time. So in this code snippet example, we use the Facet grid class to create a grid of plots. The col parameter specifies the columns of the grid, which is gender, and the row parameter specifies the rows of the grid, which is time. The map method is used to apply a scatter plot to each subset of the data. You can customize Facet grids to make them more informative and visually appealing. So for example, you can add margin titles, use different types of plots, and customize the appearance of each subplot. Here's an example of a customized Facet grid. We added margin_titles to show the column and row titles clearly. We also use a histogram plot with kernel density estimation, or KDE for short, for each subset of the data. Pair grids are useful for visualizing complex pairwise relationships between multiple variables. They allow you to create a matrix of plots showing the relationship between pairs of variables in different ways. So let's create a pair grid to visualize the relationship between several numerical variables colored by gender. In the third code snippet example, we use the pair grid class to create a grid of plots. The hue parameter specifies the variable to color by gender. The map_upper, map_lower, and map_diag methods are used to specify different types of plots for the upper triangle, lower triangle, and diagonal of the grid, respectively. The add_legend method adds a legend to the plot. Regression plots are useful for visualizing the relationship between two continuous variables and fitting a linear regression model to the data. They help in understanding the trend and correlation between the variables. Let's create a basic regression plot to visualize the relationship between the total bill and the tip. In this example, the regplot function creates a scatter plot with a linear regression line showing the relationship between the total bill and the tip. You can customize regression plots, unsurprisingly, to make them more informative and visually appealing. So for example, you could add a hue parameter to color the data points based on a categorical variable, use different markers, and customize the line style. Here's an example of a customized regression plot. In this code snippet example, the mplot function creates a scatter plot with a linear regression line. The data points are colored based on the sex column with different markers for each gender. The line_KWS parameter is used to customize the line style, setting the line width to 2. You can use the Facet grid class to plot multiple regression models for different subsets of the data. This is useful for comparing relationships across different categories. Let's create a Facet grid to plot regression models for different times of the day. Lunch and dinner, split by the gender. In this specific example, the mplot function is used to create a grid of regression plots. The column parameter specifies the columns of the grid, and the hue parameter specifies the variables to color by, so we'll choose gender. Different markers are used for each gender, and the line style is customized with line_KWS. To make your plots more informative, it's essential to add titles and labels to your plots. This helps viewers understand what the plot represents and the variables involved. Let's add a title, x-axis label, and y-axis label to our regression plot. Legends help viewers understand the meanings of different colors, markers, or line styles in a plot. Customizing the legend can enhance clarity and ensure it doesn't obstruct important parts of the plot. Here's how to customize the legend, as shown in the code snippet. Annotations can be used to highlight specific points or areas in a plot, providing additional context or drawing attention to important details. Here's an example of how to add an annotation, as shown in the code snippet. Customizing the axes and grid lines can improve the readability and aesthetics of your plots. For example, you can rotate the x-axis labels for better visibility and remove the top and right spines for a cleaner look. In this example, the plot.xtext function rotates the x-axis label by 45 degrees, and the sns.dspine function removes the top and right spines from the plot. Seaborn is built on top of matplotlib, which means you can use matplotlib's functions to further customize your Seaborn plots. That's a win-win. This allows you to take advantage of matplotlib's extensive features while benefiting from Seaborn's high-level interface. So here's an example of how to combine Seaborn with matplotlib. We'll create a box plot using Seaborn and then use matplotlib functions to set the title and labels for the plot. This combination allows for detailed customization of the plot's appearance. Seaborn integrates seamlessly with Pandas, allowing you to create plots directly from Pandas data frames. This can streamline your workflow by enabling you to manipulate your data with Pandas and then visualize it with Seaborn. See what I'm saying? In this example, we create a scatter plot using Pandas's plotting capabilities and then overlay a regression plot using Seaborn. The AX equals plot.gca parameter just ensures that both plots are drawn on the same axes. You can use advanced matplotlib features to further enhance Seaborn plots. This includes adding titles, customizing tick labels, and more. In this example of how to enhance a Seaborn heat map with matplotlib, we create a heat map using Seaborn and then use matplotlib functions to add a title and customize the rotation of tick labels. This combination provides greater control over the appearance and readability of the plot, which you could then use in your presentations to your stakeholders. A good title is crucial for any data visualization as it provides the first piece of information viewers typically see. So make sure your titles are clear, informative, and directly related to the data presented. Here's an example of setting a clear title. This title clearly indicates what the plot is about, making it easy for viewers to understand the context at a glance. Colors are a powerful tool in data visualization, but they should be used carefully to avoid misleading interpretations. Use color palettes that enhance readability and provide a clear distinction between different data points. Also, cluttered visuals can be confusing and detract from the data's message. Simplify your plots by removing any unnecessary elements and focus on the data itself. One way to do this is by removing the top and right spines using Seaborn's dspine function. This will help in creating a clearer and more focused plot. Maintaining consistent styling across all of your plots give them a cohesive look and make them easier to interpret. Set a consistent style and context for all of your plots using Seaborn's set_context and set_style functions. By doing this, it'll ensure that all your plots have a similar appearance, making your visualizations look professional and polished. Clear labels of axes and important data points is essential for understanding the plot. On the 5th code snippet, it shows how to label axes and annotate a specific data point. Adding context to your plots helps viewers understand the data and its significance. You can add contextual information using the fig text function. This code snippet adds a piece of text below the plot, providing context about the data source and time period. By following these best practices, you can create effective and professional data visualizations that are clear, informative, and engaging. Your stakeholders will be asking you questions left and right. So that's all that I have regarding data visualization with Seaborn. I hope that by now you have a better understanding of using Seaborn for data visualization. So if you have any questions, comments, or suggestions for any new video topics, leave a comment down below. Also, if you aren't already, subscribe to my channel and click the bell icon to be notified when I post another Python series video. Thanks for interacting with Tech Talk with Tyler, and I'll see you later.